In this lesson, we will go through an example of stoichiometry calculations with gases. Let's take a look at our problem. If 10 liters of carbon monoxide and 20 liters of molecular hydrogen react according to the equation below, what volume of which reactant gas remains? The volumes are measured at 250 degrees Celsius and 140 kilopascals. Let's begin by noting down all the information we've been given. From the problem, we know that the volume of carbon monoxide gas is 10 liters, the volume of hydrogen gas is 20 liters, the temperature is 250 degrees Celsius, which we must convert to Kelvin by adding 273.15, and the pressure is 140 kilopascals. Since we've been given the volume of both reactants, we know that this must mean we have to determine our limiting reactant. Now, it might be your first instinct to convert the volumes of gas into moles in order to perform the stoichiometry calculations. But let's take a look at the ideal gas equation. We can see in this equation that if the temperature and pressure were to be fixed, the number of moles is directly proportional to the volume. Thus, when the volumes of all gases in an equation are measured at the same temperature and pressure, the stoichiometric coefficients can be considered volumes. Having said that, let's move on to determining our limiting reactant. We'll start by calculating the volume of C5H12 that will be produced if all the carbon monoxide is used. We can calculate this by multiplying our 10 liters of carbon monoxide with the ratio 1/5, which is the mole ratio of C5H12 to carbon monoxide. The liters of carbon monoxide cancel out, and we are left with 2 liters of C5H12. We'll now do the same for our second reactant, H2. We'll multiply our 20 liters of hydrogen with the ratio 1/11, which is once again determined from the stoichiometric coefficients. The liters of hydrogen gas cancel out, and we're left with 1.82 liters of C5H12. Comparing our two calculations, we can see a smaller amount of C5H12 is created when all 20 liters of hydrogen gas are consumed, meaning this must be our limiting reactant. Now that we know this, we can calculate the liters of carbon monoxide we would need to react with all our hydrogen. We can do this by multiplying the 20 liters of hydrogen gas with the ratio 5 liters of carbon monoxide for every 11 liters of hydrogen gas. The liters of hydrogen cancel out, and we are left with 9.1 liters of carbon monoxide. Now on to the last step. We started with 10 liters of carbon monoxide. We used 9.1 liters in our reaction. This means our remaining carbon monoxide is 10 minus 9.1. Thus, 0.9 liters of carbon monoxide remains.